Welcome, everyone. Thank you for joining us here today. Please find a seat. The early birds are sitting on the exit or on the aisles, so you have to go all the way over to the center. We are actually more than fully subscribed today, so it's much like that Southwest flight. All seats will be taken. So please take your bags off the seats next to you so that everybody can sit down. My name is Wade Crowfoot, and I serve as Deputy Cabinet Secretary for Governor Brown. In that capacity, I help to coordinate our drought response efforts, and so I'm very happy to welcome everyone here today. We've invited a broad cross-section of leadership from across the state to participate in this conversation, not only to be here as attendees, but actually participate. And I want to, if I can, conduct a snap survey so that you all and we up in front can understand who's in the room. So please raise your hand if you're from a local water agency. All right, you have some. Raise your hand if you're from a technology company or an investor for a technology company. Great. How about if you're from academia or an extension program? Fair amount. State government. All right, a fair amount of us in as well. Non-governmental organizations. Good, we have a good cross-section. Raise your hand if you're from another type of group or affiliation. Farmers. Oh. Says the chair of the State Board of Agriculture. Farmers, local governments, not local agencies, local governments. All right, a few of you. So this is great. This was our intent, to really bring together diverse expertise here today to really explore two questions. One is what's happening in regards to technology and water in California currently, and what's around the corner. And then secondly, and maybe more importantly, how can we collectively expand deployment of technology to use water better in California? So those two questions will be explored today. First, in a plenary session led by our Natural Resources Secretary, John Laird, this morning, really looking at the state of play in technology and talking about what may be coming up here in the future. And then our plenary in the afternoon will focus on that question of, well, what should we be doing to expand deployment of technology? We'll have a deep dive session before lunch, which you'll have an option to break out into 3 specific conversations to delve into a specific area of this broad topic. It's important to note that these deep dive sessions are not more of the presentations and plenary discussions. They're active dialogue. So everybody should be prepared to share their perspective and contribute. In each of those breakout sessions, we will have note takers, as well as we have our water policy folks taking notes here in these plenary sessions, and we'll be producing a report of this summit to really capture the key takeaways. Additionally, at the end of the day, we'll ask one of the facilitators from each of the breakout sessions to join us for the final plenary to really distill key findings or key takeaways or insights from each of the breakout sessions. So while you'll only be able to attend 2 of the breakout sessions, you'll hear some of the key findings from all 6 of the breakout sessions. And then if you're able to stay with us all day, you are rewarded at the end with a reception. A hosted reception, a beer and wine reception right outside, which will be a good opportunity for us to continue to get to know one another. You all probably saw that we have a technology expo, which we're calling our Technology in Action exposition. And we've asked a variety of different technologies that are actually being deployed successfully in California to come share what they're doing. And so we built our day and our schedule around your ability to actually interact with the exposition. So there'll be a 15-minute break between sessions. We'll have a boxed lunch. You'll be able to socialize with one another, but also visit the exposition. And then the expo will be running all through the reception. Today will be web streamed live, so this plenary is being broadcast on the internet as well as each of the breakout sessions. And not only will it be web streamed live, but there'll be a video archive of the day as well that you can share with others if you're interested. We've invited media to join us here today, so make sure to prepare that pithy remark that will get you in the news or in an article. But just wanted you to be aware that all of the conversations here today, both in the plenary session and in breakouts, are open to the media. Information on speakers is in your packets, so we will spare the speakers that embarrassing 2 minutes where we talk about how great people you are. save time. And so if you want to hear about a speaker or learn about a speaker or a moderator, please look at the packet. Lastly, in terms of housekeeping, we'll be keeping to a tight schedule because we really do have a packed day. So please rejoin the sessions on time. We'll start with or without you. Big thanks to two sponsors who have made this day possible. Aqua, which probably everybody in the room knows is the Association of California Water Agencies. Aqua has been a critical partner of state government throughout this drought. And really at every turn, we've been collaborating very closely with Aqua. And so as you eat your roast beef sandwich today, think about Aqua because they're enabling that lunch. And then secondly, second sponsor is Imagine H2O, which fewer of you anyways, may know about. Imagine H2O is a nonprofit group that's really focused on inspiring and expanding technology in water. And they run business plan competitions and really serve as an accelerator for good ideas and technology. So thanks to both. So without further ado, we'll get started. And we're very fortunate to have our day kicked off by a key legislative leader on the topics we'll discuss here today. Mark Levine is a member of the Assembly, represents the 10th District north of the Golden Gate Bridge. He chairs the Assembly Committee on Water, Parks, and Wildlife, which is the key committee of jurisdiction over water. In a past life, before he was a local elected official, and maybe as he was a local elected official, he served as an advisor to social media startups and high-tech startups. So he is really the perfect person to set the tone and frame today's discussion on water and technology. So please join me in welcoming Assemblymember Levine.
Thank you very much, Wade, for that introduction, and also very good to see Secretary Laird here this morning as well. It's great to be invited to join you at this summit this morning, and want to also make sure to extend my gratitude to the Office of Planning and Research for organizing the event, and of course, Imagine H2O and Aqua for being sponsors of this summit. Ask any Californian to identify the most important issue facing this state, and you will likely hear that the issue is water. You all know best how this drought has hit communities hard. California will never see normal rainfall amounts again. We probably never did. Are we being, it's right there, all right. Just wanted to make sure there wasn't anything embarrassing on the back of those slides. The uncertainty of this drought creates tremendous challenges in how we explore all means possible to get water to all California communities and industries. But this drought also creates tremendous opportunity. The drought is forcing us to closely examine our water infrastructure and our water transfer system. Our existing federal and state system was built in the 1930s and was visionary for its time. But that was a very different time from today. California's population was less than 7 million. The Golden Gate Bridge was brand new. Sacramento was home to about 90,000 people. Silicon Valley was just a farm, and technology was nothing like we know it today. The Shasta Dam is a federal project that was completed in 1942 and is located at the headwaters of the Sacramento River above Redding. To this day, it serves as the primary reservoir for the Central Valley Project. It can hold more than 4.5 million acre-feet of water. In its day, it ranked as one of the great civil engineering feats of the world. Not only does it provide a tremendous supply of water, it also serves recreational purposes that help the economy of local communities near Lake Shasta. There can be no doubt that Shasta Dam is part of a water infrastructure that has enabled California to grow and prosper. However, much of that infrastructure was built on the premise that water would be plentiful. At that time, we simply needed to capture the water, transport the water, and turn the faucet. The Oroville Dam is also a key part of California's water infrastructure. It was completed in May of 1968 and is the keystone of California's $2.2 billion state water project. Like Shasta Dam, the Oroville Dam made the most of the best technology available. The dam was, at the time, the highest earth-filled dam in the nation. 80 million cubic yards of earth and material was moved to build this historic structure. Lake Oroville is the reservoir behind the Oroville Dam and is the State Water Project's primary reservoir. Oroville is capable of storing more than 3.5 million acre-feet of Sierra runoff. This is a recent photo of Lake Oroville. It symbolizes a hard lesson. The technology worked for the population and environmental awareness that we had at that time, but not today. The message this morning is simple. Continued reliance on old technologies and old-fashioned thinking is insufficient to provide for California's future needs. When we built dams, we used contemporary technology and ingenuity. Today, we must use innovation in the service of water sustainability. We have seen other countries do this. Australia survived its worst drought on record, which they called the Millennium Drought, by making hard decisions, conserving, and innovating. Australia's drought lasted more than 10 years. California is only in its 4th year of drought. Are we ready for a drought that may go on for more than a decade? In Israel, the reality is that there is simply not enough water, even in years when there is above average rainfall. Consequently, in Israel, water recycling, desalination, and other innovative technologies have created a sustainable water supply for the nation. For example, approximately 86% of Israel's treated water is reused for irrigation. In working towards sustainability, we need to consider the uses of water and the availability of water. This seems basic, but unfortunately, as a state, we really have no reliable measure of the annual amount of water we need or the amount of water available. While we don't know the exact amounts, we do know where we have the greatest demands. For example, California is America's agricultural powerhouse. Irrigation has allowed our agricultural industry to flourish and thrive. Irrigation has truly been a miracle for the Central Valley. According to the United States Geological Survey, just 5 states, California, Texas, Nebraska, Arkansas, and Idaho, account for 52% of the total irrigated acreage of the United States. Not surprisingly, California and Texas are the first and second largest agricultural producers in the nation. This particular photo is from a wheat field in Arizona. It is not the best example of effective use of irrigation. While irrigation is a great boon, how we irrigate is very important. In many cases, we have to move beyond pouring water over fields. This photo is an example of efficient and effective drip irrigation. There are great advancements being made in subsurface micro-irrigation, and this is just one of the water efficiency technologies available today. Today, you will discuss many of these current technologies: wireless systems that allow precision irrigation, advancements in water reuse, increased recycling in the urban sector, and much more. I've authored legislation that allowed increased storage of recycled water in wine grape growing regions. I've also authored legislation allowing the use of recycled water with cattle. These are examples of actions we can take now to allow us to better manage our demand for water and our limited water supply. We also have to think about our environment and our natural resources. We live in the most beautiful state in the nation. California's coastlines, mountains, and deserts are spectacular. California is also the most biologically diverse state. We have more endemic species than any other state in the nation, meaning species that occur nowhere else in the world. Our values demand that we step up to protect our environment for our children and future generations. And it's incumbent on all of us to use innovative technologies to help protect and conserve California's great natural beauty. This is an irrigation ditch near Grizzly Island Wildlife Area. It's located in the heart of Sassoon Marsh in Solano County. Sassoon Marsh is the largest remaining contiguous area of coastal wetland in California. It contains 54,000 acres of marsh and upland areas plus an additional 30,000 acres of waterways. In winter, it is an important feeding and resting station for waterfowl traveling the Pacific Flyway. It may harbor a population of as many as 1.5 million ducks and geese. Currently, it doesn't look like it will support much life at all, wild or otherwise, and that's a tragedy. So what can we do? We must think differently than we have in the past to harness water as a resource. We have the tools to be smarter about how we plan for and use water. This is an image of an atmospheric river. Improvements in satellite imagery revealed that winds from storm events can concentrate water into tight bands that travel across the atmosphere and unleash heavy rainfall. The technology to better predict and monitor these events will allow us to better capture stormwater, prevent flooding, and make ourselves more drought resilient. The key is to capture water where it rains and when it rains. The alternative is to change the natural flows of rivers and streams and to allow rainwater in large coastal urban areas to wash out to sea, as we have in the past. Imagine for a moment the potential of spending $1 billion to maximize storing more than 3.6 million acre-feet of water. We can do this by cleaning up contaminated groundwater aquifers in Los Angeles County. Urban runoff volumes in Los Angeles have increased by more than 1,000% in the last several decades. Utilizing stormwater runoff for groundwater recharge could result in greater self-sufficiency for the Los Angeles basin. This would help all of California, as Los Angeles imports 85% of its water supplies from the Eastern Sierra, the Colorado River, and the Delta. It would help by providing a level of flexibility that we do not currently have. We must have those kinds of alternatives to support the environment and also relieve urban pressure on our water system. The State Water Project currently contracts with Southern California to deliver up to 2 million acre-feet of water from the Delta. This is almost half of all State Water Project exports. Additionally, approximately a quarter of the State Water Project water goes to the Central Valley for irrigation and agricultural use. All of that water passes through the Delta. Sitting here today, we do not know how the potential additional water freed up from the greater self-sufficiency in Los Angeles would be used, but developing the ability to harness that water will open the door for those next steps and types of questions. Is the water crisis the result of too little water or the inability to maximize the water we have? Can we fallow less agricultural acreage? Can cold water releases be controlled to produce healthier rivers, but result in less water flowing into the oceans? How do we ensure that efficiencies gained at the meter result in lower costs? California is home to some of the best technology and creative minds in the world, the people in this room being a prime example. 30 years ago, Governor Brown laid the foundation for what is now California's booming solar energy industry. We did this by looking to the future and not getting locked in the past. We're at a critical confluence for California water. We need to combine our existing water infrastructure with innovative technologies to create a new approach to water. This new approach would do the following: respect our existing water supplies, both locally and as a state, fully explore and utilize new innovations. We simply must increase our water technologies competency, provide reliable delivery to all communities, homes, and industries. No California community should be without safe and clean water, and protect our natural resources and the environment for future generations. We have learned from our past mistakes. This approach is something we must do, and you can all help make that happen. Please view today as an opportunity for collaboration and sharing of information. While none of us can make it rain, I'm confident that the minds in this room can make the most out of every drop of water. As chair of the Assembly Committee on Water, Parks, and Wildlife, my office and the committee are resources available to you. Please do not hesitate to call on us, and I thank you for being here this morning, and enjoy the rest of the day.
Thank you, Mark. That was a great framing for today, and you can see why he has to pay attention to each piece, water, parks, and wildlife. They were all represented up there in what he did. I, in a moment, going to introduce two speakers that will frame a panel, and then the panel, but I was asked just to briefly make some comments that sort of frame the day and that. And I have to remark on the fact that I walked over here this morning and I needed to use an umbrella. And I moderated for Western governors in Sacramento at the request of Nevada Governor Sandoval, a drought forum all day in the governor's office. And they had had two previous ones in Oklahoma City and in Santa Fe. And for each of them, including the day in Sacramento, it rained that day. And so I told the governor of Nevada that on behalf of California, I was asking him to schedule 200 forums in California, and we would get rid of the drought. I think there's about 3 points that I want to wrap this next panel about. And the first one is just how fast the technology changes and how we always sort of are stuck where we are but have to move. When I graduated from college, I went on a congressional staff and traveled with the Bay Area member of Congress, and there was a weather guy in the early 70s in San Francisco named Harry Geis, who had introduced a revolutionary thing, which was a 5-day weather forecast. And people thought he was a crank, that it was not based in science. And yet, it was him doing what you saw in Mark's graphic about atmospheric rivers without the benefit of technology to do it. And then the technology caught up, and what he was doing was proven right, even though he was ostracized at the time. And if you look at Reed Hastings at Netflix, he has always said, people view us as an entertainment company, but we're really a technology company, and we begin every staff meeting by talking about what we haven't done yet technologically. How do we keep abreast of what's moving in the industry? How do we make sure that we're always leading that next wave into what changes? And as a result, Blockbuster, who was his big competitor, is out of business because they didn't get the message as he constantly moved ahead. And so the thing that's happening now is that people are paying attention. That just doesn't happen on water except for a narrow window. And when I was in the legislature, in the 6 years, I was the point person on water conservation. I did the urban landscape outdoor irrigation process to lead to the model ordinance and local government ordinances, a requirement that no bond funds could go out unless you had best practices in place, that you were actually using your water well before you were planning for the next water. I did an obscure but significant compromise to allow dual flush toilets and waterless urinals to go into the state building code. Did the 20% per capita reduction by 2020 bill, and did an ag measurement bill, did a whole host of them, and it was in the shadows. Nobody was paying attention. Now, the outdoor landscape irrigation model ordinance is in the governor's executive order. We are updating it. We are using it as the basis for what we're doing statewide. So we have an opportunity. Right now, everybody's paying attention. And in the decentralized way that water is operated in California, and that's the tough thing, with 400 individual water districts that are municipal and additional irrigation districts and water contractors, the people that will be making the decisions on some of the technology we're talking about today are not necessarily top down. They are people that are out there in the field working on this. And so what's really significant is that if we can get things out there in a way that others see it, then that's the way that next wave of technology moves. And then the third thing I wanted to say is when I broke into local government in the mid-70s, and maybe I'm the typhoid Mary of droughts. I went into the county administrative office as the 1975-77 drought was breaking, and we were in charge of the response. And one of the things I remembered that was a public relations nightmare was the fact that fire departments every year are required to water test hydrants, and there's nothing that ticks somebody that's limited to 50 gallons a day per person off more than seeing thousands of gallons of water spew up in the air from a fire hydrant for the necessary testing. And so last year, when the drought was breaking, I went around to some of the departments in my agency, and I had a meeting with the executive management of CAL FIRE. And I said, you know, the problem that happens in droughts is that people do not think outside of their normal practice. They just, well, we always do that, and they don't realize that what they always do might be a public relations or water-saving nightmare. And one of the things that I brought up was the hydrants and the fact that they just shoot up in the air and nobody gets it. And it was really interesting because everybody got quiet. Nobody had thought of it. They were just all prepared to make sure that it happened everywhere across the state. And lo and behold, about 3 months ago, I go out to get the paper in Santa Cruz on the weekend, and there is water gushing down my gutter. And I walk around the corner, and there's a fire hydrant just shooting. And all my neighbors standing out there, and one of them says, "You're in charge. Why don't you do something?" You know, and so amazingly, there is an article that appeared in the Santa Cruz paper 3 days ago about the fact that there is an emerging water technology that is being used in San Jose, other places, and is being tested in the Soquel Creek Water District that hooks up a mobile water thing to a fire hydrant, takes the water into a truck, is able to water quality test it and filter it to see that it's okay, and then reuse all but 250 gallons of the water. So what was 22,500 gallons of wasted water in the middle of the drought is now 250 gallons, with the rest going back to use, all because of an advance in technology. And believe me, it was not government incented. It was something that somebody on their own decided to do, decided to test, sold to some local governments. Other people are seeing it, and it is moving across the state in a way that it will really help us. And that is what today is about, is how do we find out what people are doing? How do we find out what people see are the needs? How do we learn that somebody else is doing something that we want to do? How do we go out and look at the exhibits and realize, geez, I hadn't thought of that. I should be using that. So today is the opportunity to focus on that. I'm very excited about it for another reason, which is there's nothing that's more crazy making than somebody calling you and saying, I have the solution, and being just crazed that I won't drop everything I'm doing, meet with them in the moment, and figure out how to integrate it. And so this is part of a systematic process that is going on in state government to make sure people are heard and we can figure out a way to do that. So that's what's exciting about today. And with no further ado, what we're going to do is we're going to have two presenters, one that's going to deal with water technology in agriculture, the second one in water technology in the urban and residential sector. They're each going to present, and then we're going to have these four panelists come up, make brief introductory comments in response, and then in whatever remaining time, I will ask them questions, and we will have a discussion about that. That is sort of the foundation for what we're going to be doing in the rest of the day. So with no further ado, The first person is going to be David Zoldowski from Cal State Fresno, who's going to talk about water technology and agriculture. And then following him, and I'm not going to introduce her, she's just going to come up to the podium when he's done, on water technology in the urban and residential sector, is Heather Cooley of the Pacific Institute. And when Heather wraps up, the four panelists will move up and off we'll go. So with no further ado, let's welcome David to the podium.
And thank you to the governor, the governor's office for putting this on. Obviously, this is of interest to many, many folks in California, and I'm going to speak a little bit to what's going on in agriculture. I work for an organization called the Center for Irrigation Technology at Fresno State. We've been there about 35 years. I've been there 32 of those years. We have a hydraulics lab. We test irrigation technologies. We like to think of ourselves kind of the UL of irrigation equipment. And so we have a history of looking at things, and I'm going to share some of that with you today. The three questions to be answered, or at least addressed, I don't know if I'm going to be able to answer them all, are the three you see on the screen. What technologies have been successfully deployed and to what scale? What new and promising technologies are not yet commercialized? That black box that everybody hopes is out there. And then what challenges exist to expanding or improving technologies for ag irrigation? So with that, if I can operate the equipment here. There we go. So what technologies have successfully been deployed and to what scale? This is just a depiction. The blue line on top is surface or flood irrigation that gets targeted as an inefficient irrigation method. And the light green line, I think if I'm not colorblind, coming up and actually meeting the flood or surface irrigation that they actually are about to meet. That's California, that's acreage. And that's by use of technology. So you can see that farmers are getting it. We understand that drip micro has many, many positive attributes to managing water, increasing crop yield, and all those things that we hear and know about. One of the things I like to ask a group like this, who in here believes that plants use less water with drip irrigation? Does anybody have a feeling that that's happens? True? Not? True? Okay. The fact is that plants typically use more water with drip irrigation. There's this little misnomer that there's some magic there. And why is that? They actually produce more fruit and vegetables typically. They're well watered. They're irrigated many times every day, maybe multiple times a day. With surface or flood, it's periodic. There's a drying out of the soil. The plant actually goes into a little bit of stress and uses a little less water. And what do we get? Less fruits and vegetables. So what we do get typically is a better reduced amount of applied water to the field with drip and micro, and so there is the water savings on the input side, and on the output side we tend to get better yields with the water we use. So I thought about this, we talked about it. What technology in the drip micro world, if I had to pick one, what is the champion product out there that has sort of set the industry forward and improved its performance? And it's the pressure compensating drip emitter. A little humble device up there that probably costs somewhere between 10 and 20 cents. It can be either put online to a tube or actually manufactured in-line. And what I tried to depict here, I don't know if I did successfully, but up here on the left is low pressure and on the right is high pressure, but that little device will give you the same flow rate, the same amount of water to each plant, regardless of the pressure in the field. So if I had to nominate a technology in the drip micro area for best in field, if you will, for contributing to water use efficiency, it would be the humble pressure compensating emitter. And I would say to you that that is being widely deployed today, particularly in trees and vines. There's 2.5 million acres or more of drip irrigation micro on trees and vines in California, and that number is just growing. I would also share with you, I did a little informal survey before this meeting today, earlier in the week, called a number of irrigation dealers. They've been ramping up at 50, 80%, 100% a year in growth the last few years. You saw that curve going up. They are struggling to get teams in the field to install. If you were asking them, they'd probably tell you that they could double the acreage they could put in next year. But I think we're starting to get up that upper limit of trained folks to install. We had a call from a dealer the other day that was looking for 3 irrigation designers. So that just tells you what the demand is the point I'm trying to share with you, that the ag community gets it. They are moving as fast as they can to drip and micro, and we expect that trend to continue. So what new and promising technology is not yet fully commercialized? And I threw the humble water meter up there in the corner. We've got some data. We looked at 23,000 wells, and we think about a third of them have water meters in the ag side. So about 32% or so have water meters. Not really sure how many of those actually operate and are working or actually used to manage irrigation, but so about a third of wells we believe out there, ag wells, have water meters on them. And as we look at technologies that aren't broadly adapted, I think the water meter fits that bill. I think it's really important. And if you're a student of Peter Drucker, he says what's measured improves, and that was obviously on the manufacturing side, but I believe that holds true in the agricultural side. And I know on the urban side, every home now is supposed to have a water meter. There's a reason for that. So, but I wanted to just point out some of the technologies that are out there. I'll start on the top. We've got weather stations. We've got soil moisture sensors, this little white cap here in the ground. We can measure plant leaf, the plant itself directly. We've got drones. You've heard about drones, and we can fly the fields now. And we can actually look at non-uniformity in the field related to irrigation or soil types and other things. And then this mapping down here, I think that's really part of the future. There are vineyards that are have installed irrigation systems that are irrigating just several vines across whole fields. And what you see here on this red and the green, those are differences in water holding capacity or soil type. And what happens if you irrigate that field as a single area, the ones in the sand tend to dry out faster. And it's very difficult to get uniform production across that field. And at harvest time, if you run a grape harvester through there and harvest the whole field, you've got some that is immature, some that are just ripe, and some that are overripe. So ideally, if we can then have subunits in that field and irrigate those plants, ideally individually, then we can manage the soil and the variability around each one of those plants. So each one of those comes to maturity at the same time, single pass harvest, better quality grapes, better wine for those who like to drink it, and hopefully a smaller price. And I can tell you this week over in our lab, we're testing a smart sprinkler that actually has a little generator in it, and as the water pressure makes it spin around, creates a little electricity, has a little radio in it, and we can talk to individual sprinklers out in the field and tell them to put more water on or less water, stop, and control them individually. So again, we can address the variability in the field. This is kind of some of the high-end stuff that's going on. And we'll get there, and we are getting there. We know how to do it. It's just kind of expensive at the moment. So I threw this one in here. These are existing irrigation drip systems, and you can see that there's a whole range of uniformity. Non-uniformity is the enemy of irrigation efficiency. Systems that aren't in the green area, which is presumably relatively uniform application of water, no matter what technology used to manage it, you're still managing a bad system. So the message I'd like to share with you today, and these are existing systems, and this is just an example of some data that was collected in the field, about 400 systems. Above that is a picture. I've actually got out behind my desk a little more recently and gone to a couple growers' fields. That's some data that I collected. That was on a farm that was on the top 5% in production in the state in their particular commodity. They sent out irrigators every day to make sure that all their micro sprinklers were operating. Unfortunately, the irrigators were not properly trained in cleaning out those devices, and there's little parts and pieces that weren't getting put back in when they opened them up and flushed them out. Their little diaphragms and stuff were laying on the ground, and so you ended up with parts of those micro sprayers not compensating for the elevation and pressure changes. And so we think that's relatively common out there. I was at another farmer's field up in Merced County, looked at a row of trees that looked a little shorter than the rest, walked out to the center. There's a little screen in the middle of where the water comes up into a T. It was plugged. I cleaned it out. The water started to flow again, and the grower looked at me and said, "I didn't know that was there." A 5-year-old system. So, just the basics, many times they take the keys to these irrigation systems and perhaps there's not enough time with the proper maintenance and operation, or it's something they think they'll get to later. And sort of the last, I live east of Fresno, and my neighbor farms over 200 acres and a second generation, probably in his early 50s. And we're in Fresno Irrigation District, and so they've gotten surface water, good rights to those water. Stuck his head over the fence the other day because now he's having to pump it, and he says, can you help me schedule my irrigation? Okay, and this is, they've been farming for 40 years, and for the first time, they're asking those kinds of questions. So what I'm really trying to share with you a little bit, hint, hint, is that low tech is high tech, and no matter what technologies we throw on these systems, if they're not operating as they need to operate, we're not going to get the maximum performance out of them. So this is a microsprayer system and operating as it should. You can see the nice uniform wetted patterns out there to get the roots out and make sure that they're well anchored in the soil there. But we believe in auditing, and what that means is you go out and periodically check these systems and making sure that they're performing as advertised and designed. I guarantee you every grower I talk to thinks that their irrigation distribution is in the 90s, right? Because that's what it was when we turned it on. Those systems tend to degrade over time, and sometimes not even knowing it. We've seen examples where there's small trees and tall trees out in an orchard, and you go talk to the grower and he says, what's a soil problem? You go out there with a probe. The probe doesn't go down with the small trees and goes down 4 feet with the big trees. Guess what? It's a water problem. So it's a distribution problem. So again, it's about educating that the systems are performing properly and that we're getting the results that we expect. Irrigation scheduling. Can't speak enough about this. Needing to know when and how much water to apply. Absolutely critical to the growing process. It's an art and a science for sure. There's lots of data that goes into making those decisions. And you're going to hear, I think the theme today many, many times is that information is important to decision making. We actually did a survey of almost 100 growers on the use of soil moisture sensors. 60% of those growers, when they started using them, reduced their applied water by almost 9%. 20% had no change in applied water, and 20% actually used more water. They were deficit irrigating. And when we aggregated all those growers over all the acres, if everyone were deploying soil moisture sensors to help schedule their irrigations, there was a per acre reduction of about 4% applied water. And if you presume that we consume 25 million acres of water and ag, that's 1 million acre feet. So the power of big numbers, right? And so it's all important to be sure that we know what we're doing. So if we know what's coming out of the well and we know where it's going and how deep it is, we can attack a couple problems, right? We've got over-irrigation that drives nitrates to the groundwater. We're trying to manage our water supplies. So we just need to make sure that we find these common solutions that can attack these common problems. And so here's my summary. Pretty simple. Educate the grower, provide them information data in whatever forms is appropriate for them, and make sure it's actionable. Just don't give them a number or a piece of information that, oh, well, I think that's good, right? What do I need to do? And then incentivize those corrective actions. And so if I was going to give one message here to Sacramento, let's be strategic and be targeted with our funds. We're limited funds. We're trying to put them in the field. Let's not just scatter them to the wind and have some fall on rock and some, all that kind of stuff. Let's absolutely make sure that we're strategic about our application and that it's meeting the goals and the objectives that we want to achieve as a state. And then after we've done that, let's go back and educate the grower and take them up the next step, because every grower is not the same. We've got high tech with drones. We've got folks asking me over the fence line, how do I schedule my irrigation? I've only been farming for 40 years. So with that, I'm going to close my remarks and thank you again for the opportunity to speak to you.
So thank you. Thank you for the opportunity to be here. I'd like to thank OPR and Aqua and Imagine H2O for putting on this very important event. And really is a pleasure to be here today as we explore opportunities to leverage technology to build a drought-resilient California. In the time available, I want to focus on 3 areas. First, on efficiency, customer efficiency, but also on water system management, and then finally on opportunities for new technologies to expand supply. I really have 2 key messages. First, that existing and new technology have enormous potential to build a resilient water system for California. But new and innovative technologies alone are not enough. We must couple those technologies with innovative policy and financial instruments in order to realize that potential. So I want to start and start at the basics, talk about household toilet water use. As Secretary Laird pointed out, California has been a leader in implementing policies and practices that help develop and promote innovative technologies for California, especially for appliances and fixtures inside the home, and the toilet really is one of those examples. Old 1980 era toilets used about 6 gallons per flush, and we estimate that in 1980, household toilet water use was almost 800,000 acre-feet. If we had continued using that technology, our household toilet water use would be 1.2 million acre-feet today. That's tremendous amount of water, but fortunately, through the implementation of standards and codes and through new technology, we were able to reduce that dramatically. And in fact, when we look at water use, it's 640,000 acre-feet less than it would have been. As you might imagine, that is, if we are at that level, the level there, if we are still using 1980 technology, this drought would be much worse. We would have to build much more infrastructure, we'd be using much more energy to move that water, treat that water, and we'd be spending a lot more money. So it's provided tremendous savings. But I would argue there's still enormous potential. By adopting even more efficient toilets using 1.2 gallons per flush, we can provide even additional savings. And as I'll talk about later, there are even new technologies that can go further. But on the toilet example, and this really gets to sort of my second point, new technologies are not enough. This figure is showing toilet flush volume in single-family homes in California. It's based on a sample of 1,500 homes in 7 water districts across the state. And as you can see, toilet flush volume varies tremendously. The ones shown in blue meet about the 1.6 gallon per flush standard, which was passed at the federal level in 1994. But as you can see, there are an enormous number. In fact, half of the toilets that are in use in these areas exceed that standard. And again, that was a standard that was put in place 20 years ago. So enormous potential here. We have to be thinking not only about the technology, but about the policies and the financing instruments in order to realize that potential. Continuing looking at household, and I look at household, although I will acknowledge there's tremendous opportunity in the commercial and industrial and institutional sector. But still focusing in on household water savings, as we talked about toilets and the potential that still it remains. But there are also potential with clothes washers, with showers, faucets, and I'll note leak repair. There's tremendous amount of water loss through leaks. And fortunately, as I'll talk in a few moments, we have new technologies that can help get at that. But in addition to our indoor savings, which we estimate are about 1.3 to 1.6 million acre-feet per year, we have tremendous potential outdoors. And fortunately, this drought is forcing us to have that conversation. There's broad recognition that lawns is not the sort of de facto standard landscape for California, that we need low water use plants. And fortunately, we're starting to implement that. We're seeing lots of rebates and incentive programs. We're seeing a real cultural shift, and I expect that will continue even when this drought ends. There are a number of new technologies that are on the horizon that can push us even further. First, the next generation appliances, things like dual flush toilets, which are common in use in Arizona and other parts of the world, but are still not that common here in California. Things like waterless or near waterless clothes washers. There's a lot of new things we can be doing that go even beyond where we're at today. In addition, remote sensing and aerial imagery. David Zoldowski talked a little bit about that application for agriculture, but there's also application in the urban sector. In particular, it can help some of the water utilities better manage outdoor water use. It can also help them potentially develop water budgets and use that as part of a pricing strategy. Third is in around social norm-based efficiency tools. This is a new and growing area. There are a lot of innovative companies that are working in this space, but this is where we're providing information, comparisons between your household water use and a neighbor, or comparisons to an efficient house. That can too incentivize conservation and can be particularly effective for some of the higher water users that may not be as responsive to a price signal. And finally, there's a tremendous opportunity with advanced metering. Almost all of urban California is metered, yet there are still some areas that are not there just yet. But what we are seeing, even in these newly metered areas, is this jump towards advanced metering. This is going to, I think, revolutionize how many utilities are managing water. It's providing much more real-time information about water use. It's helping them identify leaks. It's helping them communicate with their customers to let them know when they're about to approach the next tier, for example, or if they have a leak. It's also helping them manage their distribution system. They have much more better information that they can use to identify leaks. And you can imagine a time when we are coupling that information with smart energy meters, so we're able to manage both water and energy together. There are a tremendous amount of technological innovation that can also help us expand supply. There are opportunities for recycled water, and we'll hear a bit more about that. Opportunities for stormwater capture and even for desalination that can really help develop new and local supplies. I want to spend a little bit of time talking about water reuse. California has been reusing water for decades. This figure is showing water reuse from 1970 through 2009. The fact is we've been using recycled water even earlier in that for agricultural applications. But as you can see, it's increased. We're at about 670,000 acre feet. While it's increased, it's still a small percentage. It's only about 13% of the 5 million acre feet of wastewater that we discharge every year. So tremendous opportunity to be capturing that water and reusing it. It provides not only a water supply benefit, it reduces wastewater discharge into places like our ocean that really are adversely impacted by that. It can reduce energy use. It reduces our vulnerability to drought. So there are a lot of opportunities and a lot more applications. The single largest use of recycled water in California is agriculture, followed by urban irrigation. But as we look into the future, we'll see a broad mix of different uses, including for reservoir augmentation, including potentially for potable reuse. There are a lot of different scales that can be happening, in particular at the municipal scale, where we can be recycling and reusing water, but also capturing energy, capturing nutrients and reusing those, capturing even salts and using those for industrial purposes. There's also opportunities, though, on-site reuse. And there have been policies, for example, in San Francisco requiring that for some of the large buildings. We will certainly see more of that going forward. So to conclude, new technologies have provided tremendous water savings in urban areas over the last 35 years, but much more is possible. New local supplies have also been enabled by technology, and we will see that take off. Again, part of it driven by the drought, but also because of our long-term water management challenges. However, we cannot rely on technology alone. We must also develop the innovative policy and financing instruments to really get these technologies in place. And finally, we need better data. We need better data on how these devices are performing and how they're not performing. We need better information around how our policies are doing and implementing that. And it's only then that we will really begin to advance and move forward. So thank you, and I look forward to the next presentation.
So let's have the next panel move up. And I want to thank David and Heather for great opening presentations on both agriculture and the urban sector and sort of framing the outline of what trends have been and changes have been and where we have to go. And now we are going to move, and you can see the biographies, as Wade Crowfoot said, of each of these people in the program, so I don't have to introduce them. And what we're going to do, and I think we'll do it just in the order that they are seated, first Alex, next Jennifer, then Peter, and then Charles, is have them make some opening comments, and then in the remaining time, I'll ask them some questions, and we'll have some discussion that is in response to the opening presentation. So first we'll go with Alex. Alex, welcome.
All right, push the button. Thank you, John. It's a great opportunity to be here and at this first water technology symposium, and I'm hoping that we'll have many more of these in the coming years. So just as a sort of a context, East Bay Mud is a water and wastewater utility. We serve the greater parts of Alameda and Contra Costa County, 1.4 million customers, and we have a very large system. It's not the largest, but one of the largest retail systems. And so we have water supply reservoirs up on the McCallum River, significant conveyance systems to move water from the Sacramento and the McCallum to the Bay Area. We have 6 water treatment plants in the Bay Area, 4,200 miles of distribution pipeline. That's enough pipeline to go from here all the way to the East Coast and halfway back. We have, because there's so much topography in the Bay Area, we have a lot. We have 300 potable water reservoirs and pumping plants to move the water up, store it, and drop it down and achieve the right pressure. So very complicated system, and as a result, we have been using technology in both wet, normal, and even in dry years, always. And in preparing for this, put together a list of all the technology that I could think of in each one of those aspects, from supply through the customer. And there's a lot of it, and what's interesting is that an awful lot of it has been put in place in the last 5 to 10 years, new technologies. For our day-to-day business, technology, our key areas of focus are making sure, as you would expect from us, that we provide a reliable, high-quality supply to our customers. And in order to do that, with so much infrastructure, a big area of emphasis for us is our capital program and making sure that we can replace that aging infrastructure. That's not just us, that's a national issue. And so technology, and we maybe can speak to it a little bit more in the Q&A on our daily business, is very important. You can imagine that there are a lot of tools now that would allow you to do what used to be done with pen, paper, survey tools. You can do that a lot easier now with GIS, GPS, even your photographs, databases, all the tools that you can use, geospatial tools, to be able to put new pipe in the ground for less money and to document how you did it. So there's a lot of technology going on in a non-dry year for that purpose. It has benefits because you got to replace your pipes and your systems to avoid the leaks and the catastrophic main breaks that result in loss of water. Then in dry years, there's technology that comes to play. For us, it's interesting to note that between 2005 and 2015, in certain parts of the service area, we're seeing consumption drop by half. And the system was designed such that in 2005, we were projecting that it would be distributing more water, not less water. And so you get into water quality, water age issues in the storage and more distal parts of the surface area. And so, lo and behold, a technology has surfaced that allows us to remotely dose with ammonia and chlorine, mix at the appropriate and precise levels, maintain the chlorine residual, monitor it, and in so doing protect the public and protect our workers so they don't have to drive around and mix ammonia and chlorine in a tank. Then we have leak detection technologies. Some were mentioned, acoustic loggers, and you can now use automated metering infrastructure, which we're doing in part of our service area to match. You can have automated meters in the distribution system and automated meters at the customer, and by difference you can figure out where your leaks are and go find them and fix them. And then finally, automated metering infrastructure segues into a very important area that Heather mentioned here, and that is educating the customer. So in our higher use portions of the service area, we've got automated metering infrastructure installed that provides daily information to customers. And so when they call to say, how come I'm using so much water, my bill is outrageous, you can say, well, maybe, you know, we can share this information that you have available to you and help you appreciate that your gardener left the irrigation system on at a pretty high interval for pretty long, and that's where the problem is. And then we also are in a position to, with some of the information that you've seen outside, some of these reports, we have reports for our customers that allow them to appreciate, I hadn't heard the term before, but it's comparison with social norms, so they can appreciate what they ought to be using if they were a good water user, what their customers using. And then finally, for our 27,000 largest landscape customers, we are using a combination of GIS and satellite imagery and evapotranspiration information to give them a report that tells them what they ought to be using as compared to what they currently are using, so they can optimize and in so doing save water. So I think we'll get more into that, but that's a continuum of where we are as an urban agency trying to balance technology in our day-to-day business as well as technology for the drought. So thank you.
Thank you, Alex. Jennifer?
Yes, thank you very much, and thank you for being here. It's very exciting. I'm the Managing Director of Water Reuse California. We represent all the recycled water agencies in the state. And as Heather indicated, we really have come a long way since the 1970s when we recycled about 200,000 acre-feet. We are around 700,000 acre-feet right now and growing quickly. It's a very exciting time to be part of this organization. And as she indicated, and I've really seen in my job, is the enthusiasm and the cultural shift towards recycled water, and the public is really embracing it. We're really moving away from that because not only do we need the technology, but we need the public embracing this as well. So it's been great to see that, and it's very exciting. So with water reuse, there's obviously, we had the tremendous passage of Proposition 1, where we had $625 million for recycled water, for potable and non-potable projects. And non-potable projects we see all over the state. There's hundreds of them. They're for habitat, landscape, agricultural, industrial. So there's tremendous project potential there. And then potable projects. And this is where you take highly treated recycled water and use it for drinking water purposes. And this is not new in that, we were talking about this before the panel. You know, the public is still, is maybe not aware, but right now we have 1.6 million people in California drinking potable reuse. The total is about, mainly from Orange County Water District is really the leader in this area, but we're seeing other places as well working on potable reuse. And at this point, it's about, we have existing permits for about 200,000 acre-feet for potable reuse, so that's a lot. And we have about 23 planned groundwater and surface water projects where we expect that number to go up to about 350,000 acre-feet a year. So the potential is huge, and the future is bright. I think we'll probably get into some more detail, but as Heather said, 2.6 million acre-feet of wastewater is discharged to the ocean. If we use just a fraction of that, we're going to be in much better shape. So that's what we're about, and look forward to talking about this more.
Great. Peter? Thank you, Jennifer.
I'm Peter Williams. I work for IBM. I had a big hand in building our global water business. I'm a 16-year resident of California. Most of the technologies that are needed to solve California's water problems, I'm going to go out on a limb here, probably already exist. You've heard about a lot of them today. The issue is they have not been applied. And one of the things that needs to be done is to figure out why they've not been applied. Partly that's a function of culture and politics. Clearly that is now changing, as this meeting would be evidence. One hopes that a wet winter brought on by the developing El Nino doesn't wash all that culture change away and we revert back to where we were before. The second would be that the price of those technologies has always been too high, oftentimes, relative to the price of water. Well, the price of the technologies is decreasing dramatically. And the price of water, if you look, for example, at the work of Water Fund LLC and their water indexes that they create, the price of water is now going up, such that the law of supply and demand is now, at long last, trumping Adam Smith's diamond water paradox. That is a seismic economic change, and that is going to change the landscape probably more than any other single thing we'll talk about today. The third is the fact that California has far too many, far too small water agencies. They're not big enough to afford innovative engineers. They don't have time to innovate, and they can't finance the innovation even if they could address the first two. So there's something that needs to be done about that. So the result of that is that while the water management practices that I've seen in California, the best of them equal to the best in the world. The groundwater banking in Orange County, the riverbank filtration system that they have in Sonoma, the pump optimization and energy saving that Eastern utilities, Eastern Municipal and East Bay Mud, amongst others, do. And the groundwater banking, again, that's done in the Central Valley by people like Semi-Tropic, that's world-class best practice. The problem is that the average is absolutely nowhere near good enough. And I have a long list of horror stories I could share with anybody that might be interested. So what might be needed to address that would be something on a par with the state's approach to achieving energy efficiency. A comprehensive measurement strategy for groundwater and for surface water. The state of South Australia is building a gigantic water balance model for the entire state. Why can't California? In a lot of industries with management issues, with technology management issues, there's a framework of what is sometimes called best known practices. And industrial practices are then audited for compliance with those best known practices. One suggestion would be applying a best known practice framework to water management and indeed irrigation management in California. You could offer some kind of taxation or price relief for agencies and for farmers that are complying with those best known practices. You could actually have a water technology council, perhaps chaired by somebody like Aqua in partnership with the state, to actually choose and identify those best known practices and the circumstances in which they actually apply. You could have state sponsorship of a water cluster, perhaps building on what's already been happening in Fresno, around Fresno State, around the Blue Tech Valley initiative that you have down there. And certainly if you look at the other water clusters around the world, in Israel, in Australia, and a number of other places, those have in many cases been driven by existential need. And agriculture, water supply in California is facing a somewhat similar need, I would argue. Therefore, the motivation is there, the academic base is there. It surely ought to be possible to make the policy framework and the financing line up for that. And the final area, I would say, is going back to those very small water agencies. I guess merging them is probably somewhat controversial, but at least make them work together, perhaps within the framework of the integrated water resource management plans. In terms of making them share technology, share experience. A lot of times they share infrastructure, they share watersheds, making sure that that information is shared so each knows what the other's doing. They're not working against each other. And the final one I put in as an afterthought, and we saw a lot about it just now, mandating smart meters throughout. Probably the single biggest technology game changer that you could come up with. Thank you.
And I appreciate the fact that you used the term existential need. I'm sure that will appeal to the governor if he is listening. And he will act on it. Thank you, Peter. Charles?
Yeah, thanks. Let's see, a couple things to address a few of the things that have been said today. First of all, in these discussions, it's very important to understand that urban water conservation efforts such as low flush toilets, low flow shower heads require basically not a lot of brains and no behavioral change. When you're dealing with agricultural water, you're dealing with, okay, you have high technologies, but you're also dealing with behavioral change and lots of unknowns, weather shifts, bugs, all that kind of stuff. What's interesting, I happen to be a civil engineer and ag engineer, but in civil engineering, when we design a steel structure, we do have all the math, the properties of steel are very well known, and then you apply a factor of safety of 2. Now, that represents basically a 50% efficiency. In agricultural water, we're dealing with all kinds of unknowns and people without high degrees of expertise on water, and we're looking for an efficiency of better than 90%. Go figure, so it's a much more complex process. Second of all, there's been some confusion so far this morning about the difference between applied water and truly conserved water. You've heard different numbers presented so far about, well, you save this amount of water. Keep in mind that the problems in California are not going to be solved, by and large, by improved on-farm irrigation efficiency. There are many problems that will be, but not the water problem, because there is recirculation of most of the inefficiencies. So you have to talk about the right boundaries. In other words, a basin boundary as opposed to a farm boundary. Now, another thing, addressing expertise and so on. One of the things you'll find in displays like this and conversations is you'll find all kinds of people who have magical solutions. Australia, sorry about this, you guys. Well, I'm not sorry at all, actually. Australia has been one of the leaders in really bogus devices. You know, I mean, we have magical magnets, magical everything that come up, going to save your water, cut your water in half, increase your yield by 3 times and all that. There is no magical bullet. Guys aren't that dumb, you know. So if someone talks to you about that kind of stuff, stand back. You know, it's not worth the time. Okay, now the way you handle this
I hope
type of
there's
thing,
not a magical magnet table out there.
yeah, right. I hope so too. That said, what it is you break the problem down by pieces. First of all, this is an ag session here, but obviously if we had more water, there are less problems. That's a real no-brainer. And let me just address a couple of these. One is, I'm glad to see that California is moving ahead with watershed management to improve runoff and reduce fire damage. That's an excellent thing. Adding off-stream reservoirs like Sites Reservoir to me sounds really good. The biggest out-of-the-box solution that I've heard of so far, and I have no idea if it's any good, I have nothing to do with this, but you know, this is the kind of innovative thing that comes up, is this salinity control gates on the Benicia Bridge. I don't know if any of you have heard of it. I'm kind of curious about it. But, you know, supposedly you got the email. Okay, it sounded good to me. I don't know. But that's the kind of out-of-box thinking that we need. Okay, it needs to be investigated. And then, of course, we have looming problems on a large scale because we do rely heavily on conjunctive use, in other words, use of groundwater. And there's no doubt that the salinity and in the groundwater and the you know, problems with nitrates and all that are increasing. Eventually, we're going to have to address that, not this year. Now, moving away from water supply, you get down to the application and consumption of water. And basically, we apply water and consume it so that we can have crops, people are happy, you know, save the environment and all that. But we consume energy and impact the environment. And it's very complex. Again, the devil is in the details. There is no simple answer. It's just hard and smart work. So I'll try to break out some things. First of all, in the energy component. I'm really pleased that the California Energy Commission is going to start the first of its kind program to provide rebates for drip irrigation systems, actually with some specifications. That's new, believe it or not. In other words, a drip system can be a miserable energy hog and be designed very poorly. Hey, we need specs. That's great. So we'll be setting that program up for the Energy Commission. By the way, the center I'm in, we have about 15 full-time people, and I believe we work all over the West and in the world for that matter. But we do need research on a few things. On the pump side, the pump is the thing that drives energy. So I'm talking about the energy-water nexus right here. And that's improved bearings on the well pumps, inlet conditions for pumps, and materials to reduce sand wear. Those are research needs. On the outlet side, believe it or not, the pressure on drip systems is primarily driven by the filters. Just that little piece of hardware. We need better work on that. Basically, other than a few things, we know the pieces. It's a matter of good specifications and training. Next one, there's the water delivery. How does the water get to a farm? If the water doesn't arrive in a flexible and reliable manner from an irrigation district, with good measurement, the options for on-farm management are reduced. So we have some challenges. For example, we don't have really good flow meters for certain types of conditions. We have developed at ITRC excellent canal automation routines, and we've implemented them in a lot of places, but it's still too cumbersome. We need an out-of-the-box solution. Takes money, no interest. We have huge data collection needs for SCADA. We've been working for SCADA for years, supervisor control and data acquisition. The problem is, like with a lot of the sensors you'll see, is they have a very limited range. I think what we need is a statewide satellite system that, see, if you go straight up instead of, you know, horizontally, and you have to go through trees, I mean, that's where the problem comes in. So we need high volume, you know, access to good communications, because data management is real important. And we need this is on the water supply side, we need more realistic type environmental things. As an example, trying to get the, I notice we have some guys here from Corps of Engineers, but it doesn't slow me down. Trying to get anything through the Army Corps of Engineers is really, really difficult, and it's sometimes absolutely...
Okay, it's time to wrap up.
Oh, okay. Okay. But anyway, we have some environmental problems. Then there's the on-farm side. The problem with soil moisture sensors and that kind of stuff is that our fields have non-uniform growth and moisture contents, and so until you get rid of the non-uniformity, soil sensors and detailed instrumentation like that is not representative. So we have to do more on that. So basically we, in looking at the constraints, we know a lot about things, but for example, if you take a look at irrigation, which this conference is partly about, the irrigation programs at Utah State, Colorado State, Oregon State, Washington State, Idaho State, they've all disappeared. There's very little backing for academic irrigation programs, interestingly enough. So where's the seed corn coming from? It's a serious issue. We don't have truly user-friendly fertigation controllers. There is an absolute link between fertilizers and water and yield and quality of yield. There's very little interest in that, but we don't have an easy way for operators to apply fertilizer through the irrigation system. We need to understand better the interrelationships between nutrients. Education obviously is a huge issue. We don't know how much fertilizer, nitrogen fertilizer to apply versus how much is removed. I could go into that. People want to go to drip, but if you take a look at some crops like table grapes, people don't generally use drip. Why? They don't get the production. How about this? 1 minute. Got it. Okay. You want to put drip in Imperial Valley? There's no infrastructure for the electricity, and if you use engines, you can't, they have air quality problems. That's 500,000 acres right there with serious limitations. So, yeah, there are lists of things to do, but basically bottom line is there are people involved in it. It takes a lot better training, and it does take a bit more investment in research. Thank you.
Thank you. And yes, let's thank our panelists. And just for the record, the last person that called for a state satellite system has been called Governor Moonbeam for 40 years. So, and he was prescient. Let's play off of, in the time we have left in some of the discussion, let's play off of a comment that Peter made, which is he basically, began the discussion by saying that a lot of the technology is there, it's just not broadly applied or used. What would, he name some examples, what would many of you describe as in that category that we need to expand more broadly in California?
We just go down the road here?
Just go
All
down.
right. So that was a very good point, I believe. And I circled in the expectation of actually speaking about it a few things. So energy management systems. So the water energy nexus is very real. There are tools that allow you for reasonably sophisticated utilities to utilize your SCADA system, which is the system that controls your operations, and optimize your energy use. And in so doing, conserve a considerable amount of energy and money. You can do what's called shadow billing and run test runs and figure out how to optimize it so that you really minimize tariffs and expenses. That doesn't necessarily save water, but it sure saves a lot of money. On the customer side of the house, though, and I think many of the people in the audience must realize that the greatest use of energy to move water or to dealing with water in California happens at the customer level. And so if you're in a position to, as our organization does, coordinate or seek relationships with our energy providers, then you can see a win-win benefit by getting the customer to save water and in so doing at the same time save energy. So I think those are a couple of key areas where it hasn't really been fully developed. I also think that automated metering infrastructure, which is something that has been, it's been around, everybody's heard about it, we're all familiar with the acronym and what it means, but it still has a way to go before it's something like a regular meter that you can just go and, it's already in the warehouse, on the shelf, ready to go, battery life functional, it's been weathered and tested and so on. That's just a function of time. But that will have, when that is optimized and made more robust, that's going to have a lot of impacts on the market.
Great. Jennifer?
Thank you. Well, as I indicated before, we're really having a great interest in potable reuse in California. And one of the reasons is that the state has finished its groundwater regulations last year for statewide regulations for groundwater. Indirect potable reuse is what we call it. They're working right now to finish surface water regulation, so we'll have statewide regulation framework for this as well. And so we are doing with Water Reuse Research Foundation quite a bit of research in terms of technologies ensuring the safety of this process, looking at different technologies such as in areas where it doesn't make sense to do RO, where we have a brine issue and there's issues with how you deal with the brine discharge. How do we do potable reuse safely without that process, getting all the removal? So there's a tremendous amount of research going on in this area, and I think that is to make this application as broadly as possible. And as I indicated, this is where you're going to get a lot of big numbers in terms of the reuse of water, is putting it potentially into the groundwater basins. We need to be able to deal effectively with that brine discharge and in a safe and effective way. And I really think we're very close, but that research is continuing on. So.
Great. Thank you. Peter, anything you want to add to your own point?
You've heard about the major buckets. I'm going to add one. The major buckets, I would say, are metering, energy management, pressure and energy management, precision irrigation, water reuse. They're the four you've heard about. The fifth is leak detection and leak management, which is in many ways related to pressure management. I believe the EPA's estimated non-revenue water in the US is 14%. I never met a water agency that admitted to having 14%. It's kind of like Lake Wobegon, where all the children are above average. But 14%, the best practice worldwide, Singapore is about 2. Berlin, I believe, is about 4. That's what you've got to go after. There's 10% of all of the water put in a pipe in California is wasted because it leaks out through a hole. There's a 10% saving right there. So I would say, in addition to everything you've heard, that leak detection, which is heavily related to pressure management, is the fifth kind of bucket you want to be looking at.
Great, thank you. And is Israel somewhere in that list of 2 or 4% or a low loss?
Israel has a state target, and Laura Shenkar's here somewhere, she'll know more about that, but Israel has a state target, I think I'm right in saying, of 14%, and all their water agencies claim 13.9. So
if we just set it at 2, they'd all claim 1.9.
Precisely.
Charles?
Yeah. There are a lot of technologies that are out there that are underutilized. I mean, if you look at variable frequency drives, for example, people don't really know when they sell them, they don't even know what they do and how well they are. I mean, just as an example, I think one of the biggest things that can be done is if the state is going to have programs where they give grants and rebates and so on, they just have to have good specifications as opposed to just giving things out like, performance specifications. That would really raise the industry. One thing that hasn't been brought out is in the agricultural world, the key things, two of the key groups that haven't been mentioned are the irrigation dealers. You see, they're the guys who design the systems and put them in. And if you have a bad system to start with, you're up the creek. The next one is the consultants. And those guys need to be brought into the fold better. Not that they aren't already, but more,
Great. How about something that's in use outside of California and either hasn't been scaled for California or is it not in greater use in California? Is there anything on that list for any of you? Peter?
Yeah, in conduit hydro. It's just starting to be used. Been used in places like Germany, Sweden, I believe, and countries like that for a long time.
And why don't you explain to the uninitiated
being able to generate energy from water moving around in pipes, in particular where you have, let's say, a 36-inch main and you want to stop it down to a 24-inch main or a 12-inch main. The traditional approach is to put a gate valve in there. If instead you put a turbine in there, you still get your pressure reduction that you need and you're generating energy from the pressure that's released as you do it. And some of these things are non-trivial. I mean, they're fairly hefty amounts of energy.
Great. Others?
I've worked in at least 27 countries. I get around a lot on practical things, and I really haven't seen that we aren't using things. I think it's a mistake, and I know this may sound provincial, but it's a mistake to always be looking overseas for some magical answer. I really see that we have this stuff here. It's a matter of applying it.
Alex, Jennifer,
agree.
anything to add?
Go ahead, Jen.
I like that last comment. I think we have the stuff here to do it. Go ahead.
We pick up on Peter's comment about leaks, and yes, our organization, like many others, has leaks. But I think Europe has some technologies that, or at least some ideas about sub-metering your distribution system so that you can better understand what the water quantity is in not the whole system, but just a portion of it. And the United States has got some technology that you can match with that, where one of the problems with sub-metering a system is it keeps it from being a looped system, and you need a loop system to make sure that you're reliable. So what you can do is have these, when we're testing these systems where they automatically shut down or restrict flow at night, so you can get some information on what the flow is in that area and identify the leaks. But during the day or during high demand periods, they open up so that they can allow the system to be looped again. And those kind of technologies, I think, are underutilized, and they have a lot of value. So we're exploring it for leak detection.
Great. Charles?
Yeah, one other thing also is the water districts, the agricultural water districts. We have the technology to do a lot of things, but these are tremendously expensive to build reservoirs, to automate systems. I mean, there's just no way to get around it. And that is one thing in terms of not the technology, but the process. In Australia, they invested huge amounts of money in upgrading their irrigation districts, and that has not really happened here.
And I did want to add a little bit on potential. One of the things we really like to see is that right now the agriculture sector uses the most recycled water from wastewater applications. We think there's a tremendous opportunities there to work more closely with the ag districts, especially with this drought worsening. I think those relationships are starting to form, but we need to, it's not necessarily a technology issue, it's more of where are the permitting barriers. We're going to be working with the state board on some research to be looking at this and reaching out to the agricultural community, because I think we can do a lot more there as well. And I know that they do that in Israel. I think most of their application is for recycled water.
And let me pick up on some of that with a question, and then other people can add, but it's unique in your area, which is it was mentioned, and we'll just take this as the last question. It was mentioned that in some cases there are issues with the public either accepting something, the public understanding it to either use it effectively, the public understanding it to realize it's something they need to do. In your case, there's a specific answer there, but why don't you talk about where public opinion and public acceptance plays a role, and then any of the rest of you can add in other fields.
Well, it's absolutely critical for recycled water, and it always has been. We have, starting in the 70s, dealt with people who were uncomfortable putting recycled water on lawns. We've really moved off of that, and I think people feel much more comfortable. But it is absolutely critical. I mean, we all work for my members, our boards, Alex, we're the answer to the public. So the public needs to feel comfortable in the safety, and I think the research and the efforts that we've done to really justify and quantify that there are, in fact, no public policy issue, or there's no public safety problems with any of this has really been helpful. And as I said, now we're moving into kind of the next, I call it new, but really we do have already potable reuse projects going on in the state for quite some time. Now that's increasing, and so the challenge there, and what we've been talking to the public about is, that them understanding the treatment and the intense treatment technology and the process. And I think once people do understand that, they feel much more comfortable with it.
Let me ask the others, where else are there issues of public acceptance or understanding?
I live in a suburban subdivision in Danville, and watching the debate and angst as people's lawns either go brown or don't has been one of the more fascinating sociological experiments I've seen in a long time. And, you know, the discussion of the different solutions, well, maybe we just paint it green, and apparently there are companies out there that allow you to do that. Or maybe we put artificial turf down, which in my view is an environmental outrage. It's all right for playing soccer on, but in your backyard with your kids, I don't think so. And so on and so on. So watching that kind of going on, yeah, I think the penny's starting to drop. I think people are realizing that something's got to happen differently. And certainly you're starting to see, you know, sort of snotograms appearing on the doors of people whose lawns are suspiciously green and this kind of thing, which is kind of interesting to watch happen. So there's that kind of thing going on. The recycled water one is really, really interesting because, as you rightly say, people have been recycling water back to potable for years and years and years, right? In Singapore with the new water, somebody showed a slide of that. They mix it. They started out mixing it in the public water supply at the ratio of 2% recycled to, I think, 98 original. They've now upped that a bit to about 10 or 15 or something. What they do with the rest of it, they give it to the semiconductor industry, who love the fact that it's hundreds of times purer than anything they could get out of the tap. It's ultra pure water. In fact, they actually have to put minerals back in it before you can drink it. So as soon as people start to understand just how pure that water is, and that message starts to get across, then I think I think people's minds are actually going to change.
Right, Charles, you had something.
Yeah, I'm not sure if it quite, oops, there we go. I'm not sure if it quite fits on public opinion, but one of the challenges we have is with groundwater and you know, the idea that, well, I'm entitled to pump what I want, you know. It's a difficult question because there are investments involved, but ultimately I think because we don't have enough water right now, that's going to be the issue that has to be addressed, and that's a big public opinion thing that also deals with the realities of where the water comes from and whether water rights should be, for groundwater, should be tied to the ultimate source of that water, which is often surface water. That's maybe that's off, but that's a very tough political thing that one of these days the state will have to address.
Alex, a last word?
All right. As I'd say that an area other than recycled water where we have public issues is the cost of water. And 4 or 5 years ago, I never would have expected that we'd be in a position where the cost would have gone up as much as it has in that short period of time, and that the public would actually, to some degree, have less concern about the cost than they did 5 years ago. And I attribute that a lot to the statewide message. It's been very helpful. You know, every person driving home has seen it on a Caltrans billboard. Everybody knows where we are in this drought. And everybody's pretty, I think, overall, accepting that the cost of water has to go up. And if it can go up at an appropriate and measured pace and the public can continue to accept that, that's going to allow us not only to deal with the dry year problems, but it'll allow us to deal with the every year infrastructure problems that we have as well. And in so doing, address those leaks and that. So a lot of continued public education about the value and the appropriate cost of water.
Thank you. Please join me in thanking the panel for their time.
We're just going to have you stay here for just a second. Thanks very much. And thanks, Secretary Laird. As always, you do a phenomenal job moderating the conversation. So momentarily, we'll have a short break and then begin the first of 2 deep dive sessions. At 10:45, if you want to discuss the water energy nexus, you'll come back to this auditorium. Next door in the coastal room is focused on expanding water supply, so a deeper dive into both recycling and desalination. And then in the Sierra room will be focused, I'm sorry, my mistake. If here for Water Energy Nexus, next door for a deeper dive on agriculture, irrigation, and then in the Sierra room, that discussion on expanding water supplies. Now, I'm embarrassed to say I don't know where the Sierra room is. Thanks, Carolyn. So same floor. If you want to discuss expanding water supplies, you'll need to go down like you're headed to the stairwell and then take a right. Thanks, everyone, and we'll begin at 10:45. Thanks so much.